3565. Oh, so the one with the roof?
Yes.
So this is a unit conversion question. They have this roof. So, guys, what's 10 feet divided by 5 feet? 2 feet cancel. No, that wasn't the point. But what's 10 foot 3 inches divided by 5 foot 2 inches? Ah, shit. It's hard because you have a mixture of units. Can you make both of these measurements only in inches?
Yes.
How many inches in a foot? 12, thank God. So I've asked that before, and everybody's sort of like, we're supposed to know that? So this would that be how many total inches? 2 feet would be how many total inches? 24 plus 5? 29. And then 8 times 12? 96. Plus 2? 98. And now you can do the slope. That's really all they ask. And the pitch of a roof is the slope of the roof. If any carpenters out there, yeah, use the idea of slope a lot. Yeah, actually, yeah, good. They say slope. Click that. So what would it be? What over what?
29 over 98.
Yeah, rise over run. So 29 over 98. I like it. Okay. Anything else from homework stuff? So that question was weird because it was a unit conversion before you could do anything with it. Nothing else from homework stuff? Okay. All right. I'm an optimistic fool. Where's the... Oh, I see. Can't do anything about it. Oh, hopefully it doesn't get too hot in here. All right, so let's do this. I want to do a few things on the calculator. I want to show you a few basic things. I also want to remind you that there is a calculator guide up on the website. Let me show you. Oh my God. So go to the website, there's calculate, look at TI guide. That's what that means, TI guide. The guide for the TI calculator. And it shows you all kinds of stuff. Oh my God. So be nice to yourself and print that out. Have sitting next to you while you're doing homework. All right? If you don't have a way to print things out, then come to my office. College gave me a printer, so I can use that. Pay for my ink too. So I print all my stuff at home. Oh, some joke. Is that cool? So you got that. So a lot of what we're going to talk about today will be on this sheet. All the little steps to do. So let's do something very basic. Let's try to graph a simple line. Where on this calculator should I go to graph like y equals 2x minus 3? Y equals 2x minus 3. Some of you guys might not have ever seen this calculator before. Yeah. Notice the very top row on the calculator is all about graphing stuff. In fact, one of the buttons says graph. All right. So if I hit that y equals button, God, storage closet room. I want you to make sure everybody hits your y equals. Let me know if you don't get here. Sometimes you'll hit the y equals and there'll be some weird looking shit there. Everybody got y1, y2, right? Okay, I like it. So let's put in here 2x. 2. My x button is right there. Right next to where it says alpha. There's my x button. Bam. It's like my all-purpose variable button. It's got a bunch of variables, but the very first one's x. 2x minus, and notice this. You guys see the minus button? Do you also see another button that looks like a minus button?
Negative.
Yeah, that is the negative button at the bottom. So if you mean to say minus and you hit negative instead, it's going to screw things up. Those are hardwired differently. Now we know they're both the same. The calculator treats them differently just to make things work quicker. You guys with me? So if I put 2x negative 3, it would say that's negative 6x. It would think you're trying to multiply 2x and negative 3. I want 2x. Subtract 3, right? Minus 3. Oh man, this sucks. 2x minus 3. So that's what I want to graph. So here's a silly question. What button should I push now? Yeah, the graph button. Now, some of you guys are not going to look like mine. Mine looks nice. Nah. Does anybody have something that does not look like that? You didn't do anything wrong if you did. It's just set differently. Let me see. Oh, that is. Oh, your scale is okay. Your scale is different. You got nifty y and x showing up and stuff. Oh, you got extra shit. Hit y equals. You see the extra shit?
Extra shit on the.
So let's get rid of that. Let's get rid of this sucker. Clear. Let's clear this one too, and then we'll put 2x minus 3 in this guy. Now you graph. Okay. Yours still looks a little different, right?
No.
I like it. Yeah. So here. So guys, the standard window goes from negative 10 to 10. Negative 10 to 10. Because when we graph stuff, what's one of the things that's flexible is our scale and how far we go on that scale, right? So mine is on the standard window right now. The quickest way to make yours go to the standard window is to hit that zoom button right in the middle on the top. Hit zoom, and then which one?
Out or in?
Al Gore. What?
Out or in?
Oh, sorry. No, in this case, standard. In this case, zoom 6. I was like, that's the most weird random thing. Oh, Laura would like this shit. Nobody takes me seriously. All right, so if you hit zoom 6, it should look just like this. Kick ass. Yeah. You got a little triangle in there. See the little triangle?
Yeah.
So why does this make sense? 2x minus 3. What's the y-intercept of 2x minus 3? 0, negative 3. I know some kids are like, well, you know what I mean. No, say it right. And then where would I go from there? 2x tells me the slope is 2. So I go up 2 over 1. Up 2 over 1. Yeah. There you go. All right. So thankfully the calculator understands how to graph. Costs enough freaking money. Right? Okay. Now, let's try something else. What if I change one thing on this? Go back to y equals. And make it 2x minus 30. Can anybody guess what's going to happen when I hit the graph button?
We're not going to see it.
You're not going to see this shit. Why? What changed?
The y-intercept.
The y-intercept now is way down there. So if I hit graph, it's thinking, it shows me there's nothing, right? And you start to wonder about the calculator, but it can only do so much. So what's wrong? What is this value here? Anybody remember what I said? This is going to be negative 10. And I really want it to be at least
Negative 30.
yeah, probably beyond that, right? So I can see more of this line. So I want to change the minimum y value to be like negative 50 maybe, yeah. So here's where you do that. This is called, what I always like to think about is, you got this function graph in this little room. It's just like, there it is, it's in there. It's almost like a little monster. And you have this little window that you can look at it. So if you look in the window, you don't see it, then you got to change how you're looking through the window. So of course I'm going to hit the freaking window button. So if you hit window, what am I going to change here?
X and Y min.
Y min. So I can change all these things. This is the scale. These are the max and min X and max and min Y. Currently I want the Y min. It sounds like we agreed on negative 50. Let's see if that's good enough. Is everybody with me? Just to show you an example of what I was talking about earlier. If I use the wrong minus sign, look what it does to me. What did it do? Did I use the right one? It should tell me, aw. Oh, did I hit the? I used the same one, did I? Oh, did it really? Did it really just change it itself? Oh, that's so neat. That's new. All right, sorry. Normally I have a syntax error, and you can say go to, and it would put the cursor on the problem. But it looks like the calculator nowadays is like, all right, human, let me help you out. All right, so let's make this negative 50. And then if I graph it, we see it. Yay! Now what if I wanted to see the x-intercept? Can you see the x-intercept?
No.
What would you have to change now? X max. I love it. So that window button is very direct control. Zoom in and out is not direct. It just kind of like goes out a bit, goes in a bit. And you can keep doing that. But here you can control it perfectly, the window. So if I go back into window, make my X max maybe 30. Now I can see the x-intercept also. Yay! All right, something else I want to show you. How do I find those intercepts? Well, you can actually find the output for any input that's on the screen. So for example, and by the way, everything that's related to graphical stuff is on the top row. So let's say I wanted to know what x equal to 10, what's the output for x equals 10? All I have to do is, on the top row, someday this will actually do shit what I said. You hit second trace. See how it says calc up here? I wanted to calculate something for my line. I wanted to calculate the value, the output when x is something. X is 10, I think I said. So if you hit second trace, the very first option is value. Now look at some of this other stuff. 0, minimum, maximum, intersect sounds really interesting. 6 and 7 are calculus. Let's not worry about that shit. Let's worry about number 1. Now look what happens. If I choose number 1, x equals what? So I can tell it x equals 10, and it tells you what y is. Yay! Which is not surprising. We gave it the function. It just has to throw a 10 in there. It's a calculator. What the hell? Say it.
What happened?
Let me do it again.
Yeah.
Second trace to get into calc. That second button is like your shift button. Gets you on top of the button. So I need to get to calc. So second trace. Very first thing I could do is just see what the value is for the number for x. So now I can make x anything I want to. So if I made x 0, for example, what's special about that point? That, of course, is the y-intercept, 11. So any function you graph, if you make x 0, you can see what the y-intercept is. I like it. That's useful, right? But how in the world? So I can see any value of x that's on the screen. I can't put x equal to 18 million on here because it's not on the screen. The calculator would freak out. How do I find the x-intercept? There's no way to put a y value in. So I could do something that's not good enough. But just to show you what it's capable of, that trace button. hit that trace button. And then I can try that, let's see, go up the roller coaster, and I can kind of get close a little bit. It's somewhere between 14 and 15. You guys see that?
Yeah.
That ain't good enough. That ain't, that stupid calculator costs more money than that. It should be able to figure out exactly what it is. Let me see if you guys can get this. If I said the zero of the function, the zero of the graph, that should be where the output is 0. And of course, if the output is 0, I'm on the x-axis. Does that make sense? So the idea of 0 is the same idea as x-intercept for functions. We also sometimes...
What do you mean by output?
So x is the input value,
Yeah.
and y is the output value.
Okay.
So when I say the 0 of the function, I want to know what value makes the output 0.
Okay,
Yeah.
So just on the x-axis.
Yeah, it's the same thing as saying, where is it on the x-axis? We also sometimes call it a root, because we think of the x-axis as the ground, so that's where the roots would start. So you'll see x-intercepts are called zeros, they're called roots, and then whatever else you want to call them if they're not working right for you. So if I hit second calc, that second option is 0. That's how I figure out the x-intercept. So hit 2. All right, now this is going to get a little weird. Let me stop here for a minute, because I love you guys. I get deep into this stuff, and somebody's like, I didn't know what you did on step 1. Is everybody currently with me? Has everybody got this on their screen right now that wants to play along, where it says left bound at the bottom?
Oh.
Let me do that again.
Can I get a calculator?
Sure. You have a... I'll remember. You got a...
Oh, okay.
All right.
Sure. That's top. I'm not on.
Where's your graph? So why I got it in there. Did you do the whole change the window thing?
Yeah.
Looks like you didn't change the window. So we made the window -15, 30. There we go. I have extra stuff. Let's see if I get stabbed on. Yeah, that's okay. Here you go. Yours is fast. Alright guys, so here we go. Let me get back in there. So it hits second trace to get into calculate. See that calc up there? You have to hit the shift button to get up there. And I got all these things you can do. If it was like a parabola, you know those U shapes, I could find the minimum or the maximum. That's number 3 and 4. A line doesn't have a min or a max. It goes forever. But if I hit number 2, 0 is another name for x-intercept. But here's what it's going to do. All right, now is everybody with me?
Yes.
So now it's going to ask you 3 questions. Right? What is your question? No, it's going to ask you. It's going to ask you to make a little area for it to search in. So it's going to ask you for a left bound, and then a right bound, and then a guess. I want to give it a little area to search it. So what I always tell students, because graphs get kind of weird when they really get high slope or whatever, put your cursor on the answer and then hit the left arrow a couple times. That'll be your left bound. So you hit enter. So hit the left arrow twice. 1, 2, and now I'm on the left of the answer. Enter. Now go back to the answer and hit the right arrow. 1, 2. Enter. Do you see how it's made like a little area to search in? And now for the guess, I just put my cursor back on top of the answer, or close to it, and hit enter. And that, of course, is the x-intercept. Let me do it again. In fact, let me do this. Just to make it, well, let's do this, okay? So hit second trace to get back into calculate. Number 2. Let me hit a few more over. Let me go way over here for the left bound. And then way, there's the answer, so way over here for the right bound. So you can really see, there's the area in which I'm telling it to search. And then it's asking me for a guess, so I just get my cursor as close as I can, and then it finds it. I like it. How we doing? Huh?
I have a question.
Yes.
So when I get to this point,
Hit graph. Alright, we got freakiness going on. We also changed the zoom 6. So you give me a -10 to 10, -10 to 10. But since my y-intercept is so low, we changed the window. Because I can control, I can look further down on the y-axis. And then we also, when we did that, we also said, oh shit, we can't see on the x-axis. So that's all the changes we made, and then we can see the whole thing. All right. How's everybody else? You guys all right? And again, it's all in that guide, that sheet of paper that you can print out from the internet, from the website. I'm hoping that some of you, let's see, let's do this. Go to y equals. Let's clear this. Go with it. Let's put in there x squared minus x. Why not? And whenever I put a new function in, I basically always hit zoom 6 just to come back to a standard window. Some of you guys should have expected this shape, right? X squared has got that curvy shape. We haven't officially talked about it yet. But anytime the exponent on the variable is not 1, you end up with some kind of curve. I like it.
You said x squared minus what?
Minus x.
Minus x.
Yeah. I like it. Now, I want to do this one specifically because, do you see how where's the most important point on this? Really?
The apex?
The vertex.
Vertex.
I like it.
Yeah.
So it's in here. There's a lot of shit happening right there. But it's just like a big black blob. So I'm going to do like the fake CSI shows. I'm going to enhance. So watch this, guys. One of my favorite zoom options. If you hit the zoom button, the very first one. Zoom box. Yeah. So let's hit zoom box. Now watch. Here's how zoom box works. So what I'm going to do is I'm going to move the cursor over here somewhere and hit enter. And then that's one corner of the box. And now if I hit down and over, it opens the box up. So you're going to, once you hit enter for zoom box, that's one corner of the box. And then you move over and down or up and you make a whole...
It doesn't need to be like on the line.
No, it doesn't. I can put it wherever the shit I want to. I just wanted to try to get the vertex sort of in the middle.
Okay, as long as it encompasses that third of that.
Yes. Cool. So let's see. If I hit enter, now it's going to zoom in and I can see things a lot better. Now the function was x squared minus x. If I put a 1 in, what's 1 squared minus 1? 0. So that's why it makes sense. And what's 0 squared minus 0? 0. So those are my two x-intercepts. It makes sense. When you have higher powers on x, there could be multiple x-intercepts. Because it's going to be turning all over the damn place, right? This only has one term, but still. Now let's try this. This is the last thing I'll do today, just on the calculator. Let's see if we can find that minimum, right? Because that showed up in that list of things we could do. So if you hit, which button had that minimum in it? It's under calculate right up here. So if I hit second trace, see number 3? Minimum?
Yeah.
And it's going to ask you 3 questions again, very similar. Left, right, and then give it a guess. So it looks to be about 1/2 on the x and -1/4 on the y. So that's the point that is the vertex. It's the turning point. I like it. So now you can just, I don't know. I know I'm not like a standard case because I was sitting there playing with just regular calculators back in the day when they were all red on the screen, right? Oh, yeah. So I was, it was kind of obvious what Jeff was going to do. But even, I'm not asking for that level. Just put shit into the y equals and just see what happens. It's kind of neat. There's just to show you what button should be the most intriguing to you. I would think which button seems to be like everything.
Off. No, I'm just kidding.
Which button? I like to leave that question open for my smart ass. What about that math button?
Yeah.
Holy shit. So now here's one of the most intriguing buttons. Watch. If I said 0.527, make it a fraction. Look at the very first thing in this math. Too bad for you. Anyway, I didn't let you use calculator in that anyway, so even if you knew how to do it, I did not. So now you see why sometimes my tests might have a part 1 and a part 2. Part 1 is going to have the stuff I need to make sure you can do. Part 2 is the stuff you can use a calculator to do. Right? There's a lot of stuff under math. If you go over here, there's absolute value. And then there's some weird-ass complex stuff that we'll talk about later this semester. And then there's probability stuff that we won't talk about at all. Anyway. So there's a lot of stuff. I'm sure you're not used to thinking this way. There's a lot of stuff to play with on this thing. It's not quite a Game Boy, but just to see what things look like, or not. Any specific questions about the calculator while I have it up here? Here's one last thing I want to show you. You see above graph, what's it say? Table. So if we had second graph, XY table. And you can move around. Yeah, woohoo, yeah. You guys understand? There's an XY table in there, yes. Okay, alright.
So wait, if you were to put in equation under y equals and then go to that table, would it have all the coordinates?
Yeah, watch. So these are the coordinates for this equation. If I put another equation in here, here's your to the button, by the way, right there. This is your to the 3x to the 4th, let's say, minus 7. Now if we go back to table, it's going to have both. Look, the y1 outputs, the y2 outputs. Kind of kick ass. Okay, I think that's enough technology for the moment. Okay. That's enough math, Jeff. No, just enough technology. Not enough math. Yeah. Oh, you got to look table set. So this one should be auto. What's really cool, and I'll show everybody this, but if you leave it on that, so you can actually just input your own.
Alright.
Auto just automatically populates it with standard stuff.
Okay.
Yeah. I like it. All right. So, yesterday we got into functions. I want to finish talking about functions and then give you guys a worksheet to work on. So, can you turn the lights back on? Thanks, man. Somebody tell me, is this here a function? No. All right, it's like spaghetti noodle fell on the floor, but why exactly is this not a function? What test do I use?
The line test?
Which line test?
Vertical line.
test. Vertical line test because a vertical line goes through more than once. So it fails the vertical line test. And remember, the vertical line test is a visual analog of the definition. Every x can have only one y. A vertical line is x equals. If it goes through once, more than once, that x value has more than one output. So that's why the vertical line test makes sense. It is just a visual of the definition. There will be a horizontal line test later in the class, and it's going to mean something a little different. But right now it's vertical line test. Okay, I like it. Oh. These words. What do these words mean? What does anybody know what domain refers to? The most interesting faces.
How many?
Have you ever heard of domain?
Yeah. And then how many points it can go on the y-axis?
It's not how many. Domain is related to the inputs, and which is most generally x. So domain is a collection of all the values I'm allowed to use for x. So what would range probably be, since these go together? All the values that pop out for y. So I put something in for x, out pops out a y. So domain is all the values I'm allowed to use in x. Range is all the values that come out after I plug this in. So domain is inputs, range is outputs. I like it. So here's a way to represent a question. Is this a function? I can represent it like this.
Yeah.
Why? What's the basic definition of function? For every x, there can be only one y. I like it. So what are these? X values. And these are y values. 1 has only one output. 2 has only one output. 3 has only one output. I love it. So yes, this is a function. What about this? No. Careful. Does 1 have more than one output? What's 1's output? 4. It has only one output. What's 2 output? It has only one output. What's 3's? I don't care what the outputs are, just each input can have only one output. So how would I draw it? So this still is. So I tricked you in it. Now you know this next one is going to be no. Right? A lot of you guys are like, well, that was yes, the next one's no. No. Sorry. Get pleasure out of messing with you guys. That's why I became a teacher. So what would I have to do so that's not a function? I'd have to have, like, what could I add to this so it's not a function?
3 going to 5.
Beautiful. That's not a function because now 3 has more than one output. When I input 3, I get more than one output. So if I said third person, how many brothers do you have? They said 5 or 6, depending on the day. What's going on with that dude? Is he phasing in and out? Sorry. So that, again, it kind of always comes back to what physically makes sense. Right? So this is not a function. Good Lord. And if I say explain, you tell me 3 goes to 5 and 6. Or you say 3 has more than one output, or something like that. I like it. If I ask you to explain and you don't explain, you will lose points. Sometimes you'll think it's not a function for the wrong reason. I want to know if you know the right reason. Okay, so finally, I could just give this to you. Let me shut up for a while. This is a little worksheet that starts off with function stuff, and then the last few problems actually go back to what we were talking about last time. A little review before the quiz on Monday. Yes?
And it's still 3.8, right?
This is still 3.8. Yeah. Oh, shit. Well, let me give this to you. I got one more thing to talk about. It's just chock a block full of stuff. I always forget. Just a small thing.
Oh. Yeah. Yeah.
All right, guys. One last thing. Something a lot more like technical that you can sink your teeth into a bit. Remember these kind of problems where I gave you an expression like ay minus z, and I said, figure this out if a is 2, y is 3, and z is -4 or something, right? How did you do that kind of problem? Just plug the shit in, right? It's just a plug and chug problem. This should be like, yes, Jeff, give me a lot of these. Because then it would just be 2 times 3 minus -4, 6 plus 4, 10. Now, people freak out about function notation, but fundamentally it really is just substitution. So if I tell you, this is function notation, if I tell you that f of x is 5 minus 2x, that's function notation. This is not f times x. This is plug an x into f and you get this. F of x. F of x. You can't divide by f or something weird. Right? So then if I ask you, well, what's f of 2? Well, what's the function tell you to do? Yeah, go ahead.
So 5 minus 2 times 2.
Yeah, 5 minus 2 times 2. See how it's this problem more compact? So f of x is 5 minus 2x. F of 2 is 5 minus 2 times 2. And then you just do it, right? And the reason that we start doing this kind of thing is now we can have multiple functions, whereas before they would have all been y. And I'm like, what's y if x is 3? Which frickin' y? Holy shit. Well, now I can have f function and a g function and an h function and a p function for profit and a c function for, I don't know, cucumbers. Right? So like if g of x was 4x squared, what's g of 1? Yeah, 4 times 1 squared, which is 4 times 1, which is 4. What would g of w be? What's g of x? What's g of x? 4x squared. What's g of w? 4w squared. Don't make more of it than it is. It's just whatever the hell is x, wherever that is, replace it with what's in there now. So g of w would just be 4w squared. It's just replacing x with whatever it is at that moment. All right, so now try that. Hand out.